Hello, assalamu alaikum.
Walaikum assalam. How are you, brother?
Okay, alhamdulillah, I'm fine. And you?
Yeah, alhamdulillah, it's good, mashallah.
Okay. Okay, so basically today is our second day's online training program.
Yeah.
So we will continue our today's class. Okay, so let's go. So I simply share my screen.
Okay. First of all, I apologize for the delay because I was not in my home because to drop somebody. That's why it was late. Sorry
Okay,
for half
okay,
hour
no
delay.
problem. Okay, no. So hi and welcome to the 3 days online training program on Google Earth Engine for remote sensing analysis. Okay. So basically, today is our second day, and second day's course content. First of all, I will try to discuss about the course content, what we will learn for today's lesson. So first of all, I will try to discuss about the filtering and visualizing the satellite images in Google Earth Engine platform, and we already know about that Landsat, Sentinel, all of the satellite imagery we can easily getting from the Google Earth Engine platform without downloading. Okay, we can easily get all of the satellite images in Google Earth Engine platform. Then we also try to show you that how you can easily export the satellite images from the Google Earth Engine platform, how you can easily export these satellite images. And then we also try to discuss about that how you can easily make the time series chart. Okay, how you can easily make the NDVI time series chart for the different region. Okay, we also try to discuss about that, and then how to calculate it MODIS and Landsat data for normalized difference water index, and then how to export the TIP images, as well as we also try to discuss about how to export any shape file from the Google Earth Engine platform. Okay, so today this is our course outline. So I will try to discuss all of the topics step by step. So let's go. So first of all, filtering and visualizing the satellite images. So basically, when you want to filter the satellite images, mainly it depends some factor. Suppose you want to need the satellite image for Dhaka city. Suppose you want to need the satellite image for Saudi Arabia region. Suppose you want to need the city for any region. Okay. So first of all, you need to define your region. Suppose which region you want to need the satellite image, you can simply import the shapefile in Google Earth Engine platform, and you can easily get this satellite image. So filtering first factor is that your region. So suppose in this time I want to need the satellite image for Dhaka city. This is one kind of factor. Second factor is that suppose you want to need only for those images, which image will be not more than 1% cloud cover. Okay, so this is the another factor. I filter the image properties or image metadata. Okay, suppose I want to need only for those images, which image will be not more than 1% cloud cover. So this is the another factor. Third factor is that suppose I want to need only for the image for year of 2017, or I need the any time period, summer season, rainy season. You can just simply change your time period. Okay, so basically these three factors you have must to include when you want to filtering the satellite images. It can be Landsat or Sentinel, both of images. Okay, so let's go. In this time I will try to show you the practically how you can easily filtering and visualizing the satellite images in Google Earth Engine platform according to three factors. First factor is region of, you can simply import your shape file. Suppose I want to need the satellite image for Dhaka city, so I simply import the shape file of Dhaka city. Suppose you want to need the satellite image for the other region, so you can simply import your shape file. Then second factor is that you need to filter image properties. Suppose I want to need only for those images, which image will be not more than 1% cloud cover. So this is the another factor. Third factor is that a specific time period. Suppose I want to need the satellite image for the rainy season. I want to need the satellite image for the summer season. I want to need the satellite image for year of 2017. Like this. Okay. So let's go. I simply show you all of the details practically. So I simply open my code editor. So I simply open my code editor. So just a minute, I simply open my code editor. Okay, so first of all, suppose I want to need the satellite image for the Dhaka city region. Okay, so first of all, I need to import my shapefile. And previous class, I also try to show you that how we can easily import the shapefile. From the asset tab, we can simply import our shapefile. So suppose in this time, I want to need the shapefile for this region. Suppose I need the shapefile for the Dhaka city. So I can simply, okay, so this is the Dhaka city shapefile. I want to work with the Dhaka city shapefile. Suppose I want to need the Dhaka city Landsat imagery for this region. Okay, so just I simply import this image collection. Okay, so now my image collection is imported. I want to show the layer, so I simply use here the suppose table. This is the default variable name. I change it, no problem, or keep the table, no problem. Yeah.
Can I interrupt you, Mijan? Can you go one step before? I'm not clear. Sorry for interrupt you.
Okay.
Go back again.
Okay.
Go back again.
Okay. I can simply click to here. Okay.
Here you go asset. You already have the asset for the Dhaka city.
Asset.
You have the this is the okay.
Yeah. I simply go to the asset, then simply find out my shapefile file name. Okay. And this shapefile I already imported. Yeah. This is my archive. I already imported. Okay. I simply click the import now.
Okay. Got it.
So now it will be imported in my code editor.
Okay.
The table. This is the default variable name.
Okay.
I change it, no problem. I simply change the name as a suppose ROI or Dhaka. You can input any name, no problem.
Can you make the bigger screen because it's a very small? It is possible that we remove our. Could make the zoom.
Okay, just a minute. Okay.
Yeah, this is nice, mashallah. Okay. You put the ROI. Okay, yeah. Got it. Yeah.
You can put any name, no problem. So in this time, I want to show my shapefile. I simply use here the map.add layer. Okay. And then simply press all of the things. In this time, if you want, you can simply make the dictionary and put the value, or you can simply copy the value ROI and paste here and remove all of the things. No problem. Okay. Then click to the run. So a new layer will be added here, but I did not see my area. So I simply So I simply use here the map.center object. I want to focus the center of this shapefile. My object name is the ROI. I put the value zoom suppose 10. Then click to the run. 10. So now I can get my area. Suppose this is my region. For this region, I want to need the Landsat 8 satellite imagery. Okay. So in this time, I simply go to this search bar and click on the browse data catalog. Here I find all of the remote sensing data. Landsat mode is Sentinel. I want to work with the Landsat. So I simply click on the Landsat. And all of the Landsat images, the process is the same for filtering and displaying the satellite image. All of the images you can see Landsat 9, Landsat 8, Landsat 7, Landsat 5, Landsat 4, Landsat 1 to 5. So in this time, all of the images for filtering process is the same. Okay. So I show you the Landsat 8, but you also try to for the Landsat 9, Landsat 7 and other images. So this is the best practice. Okay. I simply click on the Landsat 8. And then you can see you can also get the Landsat 8 different types of images. You can see surface reflectance, top of atmospheric, raw image. So we are using the different types of remote sensing work for different types of images. Okay. So in this time, all of them is the same process for filtering all of the things. Okay. So in this time, I want to work with the top of atmospheric. Suppose I simply click on the top of atmospheric. So here I can get all of the information about this top of atmospheric satellite images. I can get the dataset availability date. It will be start from 2013 to 0318, from 2020 to 1024. Okay. In this time, this dataset provided is that USGS and Google. Okay. So mainly when you want to randomly download the dataset from other sources, Earth Explorer or USGS website. So mainly in this time, you can see the Art Explorer or USGS website already provide the data set. We're using the same satellite image. But in this time, we don't need to download. Without downloading, just write the code. We can keep the analysis for any types of remote sensing analysis. Land use, land cover, NDVI, NDWI, any types of remote sensing we can get from the satellite image without downloading. Okay. So you can see this is the artisan snippet. So this image collection, this artisan snippet, this is the unique ID of this image collection. Okay. Unique ID. Every image collection has every unique ID. So in this time, I simply copy this. Okay. I simply copy and then I simply paste in my code editor. So I simply paste here. Okay. And then I simply, this image collection, I need to store it in a variable name. So I simply keep a variable name in here. So I take a variable and put the variable name is the L8. You can just L8. So I simply L and 8, non-space. So this is my variable L8. This variable L8 is stored my full image collection. Okay. In this time, I want to check how many images are available for the whole world between the time period of year of 2013 to present time for Landsat 8 top of atmospheric image collection. How many images are available for the whole world between this time period? So for this, I simply print.
This is the whole world.
Yeah, whole world. Print L8. I simply use the size and click to the run. So now it's showing me how many images are available for the whole world between the time period year of 2013 to this time period. How many images are available for the whole world? Okay. Basically, this image collection is the globally. Okay. So now it will be computing how many images is available for the whole world. So we can check the number, how many images are available for the whole world. So it's computing. There's a lot of images we can get in here. The calculation and it's okay. You can see it showing the more than 1 million images are available for the whole world. Okay. So in this time, I need to filter this large number of collection. Somehow I need to filter this image collection. So you can see in this time I work only for the Dhaka city. I don't need for the whole world. I need only for the image for the Dhaka city. Okay. So for this, I need a function. Which function is keep only for the image for the Dhaka city. This function, what is the function? So I write the function in here. So I simply take a variable and give the variable name is the suppose filter region. You can put any name, no problem. You can see this large number of collection is stored in a variable. This variable name is L8. Okay. I simply copy the L8 and paste here. In this time, this image for the whole world, but in this time, I don't need for the whole world. I need only for my region of Dhaka city. So in this time, I simply use a function. It's called the filter bounds. In this time, I filter my boundary. This is a filter bounds function. It's mainly intersecting with the whole collection with your region of interest. In this time, you can see what is the value. You can see geometry. In this time, you can see I already imported my geometry or my boundary and stored the variable is the ROI. I simply copy the ROI and paste here. Okay, just it. In this time, you can see this is my large collection. It intersecting with my ROI. So in this time, this variable is stored only for the image, which images are available for the Dhaka city.
Got it.
In this time, I simply use the print function again. Print. And copy the filter region and use the size function. Use the size function and click to the run. So now you can get how many images are available for the Dhaka city between the time period year of 2013 to present time. 384 images are available for my region. Okay. In this time, from the 384 images, I don't need for the all images. I want to need only for this image, which image will be not more than 1% cloud cover. I want to need only for this image. I don't need for the all of the image. I need only for the image, which image will be not more than 1% cloud cover. Okay. So for this, I simply take the another variable. Suppose filter metadata. You can put any name, no problem. And then these 384, these images are stored in a variable. This variable name is that filter region. Okay. I simply copy the filter region and paste here. in this time, I want to need only for this image, which image will be not more than 1% cloud cover. So that's why I need to use a function. It's called the filter metadata. I simply press Ctrl and space. I can get all of the argument. First of all, you can see it showing the name. What is the name? Name is the image properties name. I want to need, I get all of the image properties in here. You can see cloud cover, land, cloud, all of the image properties I can get in here. But in this time, I want to need only for those image, which image will be not more than 1% cloud cover. So my property name is that cloud cover. I simply copy this and then I simply, this is the string. I must be use here the single quote, then paste here this name. Then I also need to add here the operator. I simply put the operator is that less than. Less than, I put the value is 1.
Okay, great.
1.
Great.
In this time, I have to check how many images are available in my region of Dhaka city, which image will be not more than 1% cloud cover. I want to check it, how many images. Simply print again, and then simply call the filter metadata, and paste here and use here the size function, and check. So now I can get how many images are available. 56 images is available for my region. This image is less than 1% cloud cover. Okay, and this time period is that you can see 2013 to present time. Okay, so in this time, from the 56 images, I don't need for the whole time period. I need only for the year of 2018 or any in summer season, rainy season. You can simply put the time period. I don't need for the whole time period. I need only for the specific time period. Okay, so for this I need to take the another variable. Suppose this variable name is that filter date. Okay, this 56 image is stored in a variable. This variable name is the filter metadata. Simply copy and paste here, and then I simply use a function. It's called the filter date, and check. You can see start date, end date. I simply put the start date, suppose year of 2020, suppose 1st January, or any time period you can put in here, no problem. Any summer season, rainy season time period, no problem. I take the whole 1 year, year of 2020, December, suppose 31. In this time, I want to check how many images are available between this time period. Okay, so I simply use the print function, and then I simply call the filter date, simply copy this and paste here, and use here the size function, and click to the run. So now you can check how many images are available for the year of 2020. Okay, so I need to filter date. I simply copy this and paste here and click to the run. Now you can see I can get only for the 7 images. Okay, this 7 images is available for the Dhaka city for year of 2020. So now what is the properties of this 7 images? First of all, this 7 images is stay in the Dhaka city region. This 7 images is less than 1% cloud cover. This 7 images is the between this time period, year of 2020. Okay, so you can see, first of all, I can get the large number of collection. Okay, so more than 1 million images. I filter it according to my region. I filter it according to my image properties. I filter it according to my time period. And final, I can get only for the 7 images. Okay, so if you have any question about the filtering process, you can ask me. Any question? Anyone?
It's a great, brother. Everything understood? Go ahead. Okay,
thank you. Okay. So now you can see this 7 image is not captured by the satellite at the same time. It taken this image for the different time. Okay. So in this time, I want to check all of the images acquisition date. All of the images acquisition date. I want to check it.
Okay.
So for this, I simply print this again, and then simply copy the filter date, and paste here and click to the run. Now you can see it will be showing me all of the information about this image. You can see here I simply click to here, and you can see in here okay, so you can see in this image collection, I simply click on the feature. Here I can get total 7 images from 0 to 6, total 7 images. So in this time, I simply decrease the size, otherwise not okay. So now you can see first image. It's showing in the first image the acquisition date is that year of 2020 11th February.
Further.
Then you
Okay.
can see 26th January, 11th February, 30 March, 27 December, 9th November, 9th November.
November.
So here I can get all of the images acquisition date, and every image has a total 17 bands. Okay, we can get all of the 17 bands. Okay, every image.
So here the image, excuse me, my brother.
Yeah, yeah.
Here the image are repeating because 11 November, 17 November, 17 November. Why they giving two images?
So in this time, it showing the another tiles. So in this time, it's showing only for the tiles. Okay. Suppose in this time, the satellites capture the one tiles in here, also take the another tiles in here.
Okay.
So different
Got it,
same
got it.
time. Okay. So in this time, the total 7 images has a 7 tiles. Okay. So in this time, suppose you can get all of the images. Suppose you want to work with the specific time period image. Suppose you want to make the land use land cover classification map, which image is the acquisition date is the year of 2020, 11th February. I want to use this image. I want to use only for this image. Okay. So I simply click to here and then simply copy the Landsat ID. I simply copy this ID. Okay.
Okay.
Simply copy. And then I simply take a variable. You can put any variable name. I simply put the variable name is the image. And then I simply use here the EE dot image. Basically, this is the function when you want to store any ID. Basically, this is the ID. I simply use here the quotation, then put here this ID name. Okay. So now I want to check. I want to show the image. I simply use here the map dot add layer. And then I simply call the image variable name and paste here. So now it will display the result. You can see as a tiles. You can see one layer will be added here. As a tiles, it's showing the as a tiles. This tile, you can see this tiles has a problem. This problem is that when I clip this, you can see I simply use the clip function. I clip it with my shapefile. Shapefile is ROI and click the run. You can see it not covered my full region. This tiles of satellite image, it's not covered the some region of Dhaka city. You can see this region is not covered. Okay. This images look like this because I did not add the visualization. When I add the visualization, then we can get the proper image. In this time, you can see this tiles with the year of 2020, 11th February. This tiles is not cover my whole region. Okay, it's not covered.
Got it.
So I want to check the another image. It will be not covered. So I want to check the another image. Suppose I simply go to this feature and check the second tiles. This tile is covered or not. I want to check it. I simply copy again this second ID, simply copy, and then simply paste here instead of this ID.
Just same place here.
Just replace. Then click to the run. So now you can see it will be covered or not. We can check. Okay, so this image is the cover. You can see my full region is covered. So now you can simply when you want to work with the Dhaka city for the Landsat 8 image year of 2020. Then you have to get the image for the year of 2020, first 26 January. 26 January. So this acquisition image is the perfect for your region. In this time, this images look like this because I did not add the visualization. So for this, I simply click on here. Then I want to add here the band combination. I want to add here the true color composite. B4, B3, B2. Red, green and blue. RGB color. State 98% for better looking. And then apply. So now you can get the satellite image. You can see I can get the satellite images. Okay. And what is the acquisition time period of this satellite image? You can check the acquisition time period is that year of 2020 or 26 January. Okay. So this is my image. I want to get this image. Suppose in this time you can easily use this image for making the any types of remote sensing work. Okay. In this time we are also do for the another things. This thing is that here I can get total 7 images for my Dhaka city region for the whole year. If you want, you can also get the median image. You create the median composite using the total 7 images. You create the median image. Okay. In this time, I not work for the single image. I want to work with the median image. This median is created by the total 7 images. Okay. So for this, you can see. So when you want to work with the single image, then you can follow this process. Okay. when you want to work with the median composite for the total 7 images, then now I follow this process. You can see I simply commenting this line, and then I simply take a variable. Suppose this variable name is that I can put the variable final, so final image, okay, and then I simply call the filter date, because this 7 image is stored at the filter date. I want to make the median composite using these 7 images, so I simply call the variable and use at the median function. Okay, so now you can see when I want to show the result, I simply use at the map.add layer, and I simply call the final image, and I also need to use at the I simply clip with my shapefile. I simply use the clip with my shapefile is the ROI and click to the run. So now you can see I want to get the median composite. So basically this median composite is the better looking. Okay, so in this time, this image I want to show the visualization. You can see we can get the better visualization than other previous one single images. You can see before 3 and 2 set 98% and apply. So we are getting the better images than single images. Basically this image is the created the median from the total 7 images. It created the median composite of the satellite images. Okay, so in this time we can say I add the visualization parameter. So yeah, you are easily getting the different types of the band combination. It's called the true color band combination. If you want, you can use it at the 5, 4, 3, then apply. It's called the false color composite. Okay, basically when I'm using the false color composite, it's mainly this red pixel value is identify the vegetation, and black pixel value is identify the water body, and urban is the white, like this. Okay, so different types of band combination has to identify the different types of feature we can easily identify. Okay.
Yeah, got it.
Yeah,
Got it.
okay, so now you can see I want to add at the 5, 3 and 2 and apply. You can see in this time this is my visualization parameter. I need to add the visualization parameter with my code editor. So I simply import. You can see import. I simply click the import. A new line of code will be added here. Okay, I simply copy this, simply copy and paste after the object name. This is my object. Sorry, this is my object final image. After the final image, I want to add the visualization. So my visualization variable name is that. I simply copy this name and I simply put the layer name. Suppose true color. So now you can see now this color will be set with my code. Okay, so basically this is the process. You can see now I can get the satellite images, and now I want to work with the satellite images. Easily make the different types of remote sensing work. I can easily do for the land use land cover classification, NDVI map, NDWI map, or other types of analysis. So in this time you can see this is the filtering process in the Google Earth Engine platform. In this time I also show you the another trick is that in this time you can see every function filter bounds. This is a function filter. For filter bounds I take a new variable. For filter metadata I take the another new variable. For the filter date I take the another new variable. For the median I take the another variable. Okay, but if you want you can take only for the one variable, and under this variable you can put all of the function one by one. So in this time I try to show you this process. So I simply commenting all of the line, because I also send you all of the practice code. So you also practice, but when you want to write the code, you follow the shortcut method. Okay. So in the first time I write all of the code for your understanding how it will be filtered from the I can get the large collection. I filter it according to my region. I can get this value. I filtered this according to my image properties. I can get the value. I filtered this according to my time period. I can get the value. So how I can get the value, I try to discuss. In this time, when you can get the idea, then you can easily write the code very short way. So for this, you can see, I simply take a variable. Suppose this variable name is the image. I simply call my L8. This is my variable name L8. It will be stored the whole image collection. I simply use it the filter bounds. So filter bounds, it intersecting with my ROI. Okay. Then I simply use here the dot notation, and then use here the filter metadata, and I simply put here the cloud cover. This is my image property name, and use here the less than and put here the 1. Okay, then I simply use here the another thing is that suppose filter date, I simply put here the specific time period. Suppose I need the image for 2021 1st January and from 2021 December 31. In this time I can get, suppose I want to check how many images I want to get for my region. So you can simply the same process, you can see I simply print this image and use there the size function. Now I can get all of the filter bounds, filter metadata and filter date, all of the process after how many images I want to get. I get only for the 4 images. You want to check the image acquisition date, all of the images you can check. I want to get all of the image acquisition date, you can see I want to get all of them. If you want to work with a single image, simply copy this and just follow this method again in here. Just follow this image and you can get the display the single image. Okay, so in this time I want to not work with a single image, I want to create the total 4 images median pixel value. So for this I simply use the median, and this median pixel value it will be clipped with my shape file is that ry. I want to show the result, so I simply use here the map dot add layer and then I simply call the image.
Can I have one question, brother?
Yeah.
You have the 4 images for this particular date,
Yeah.
31st December 2021 and January.
Yeah.
So what is the function for median? For it take the all 4 image median value?
Yeah. All of the 4 images take
Why
the
we
median
taking
value.
median? Why are we taking the median? Because of what?
In this time you can see we are taking the median. For median this is the reducer. Okay, so in this time I can get the total 4 images. When I take the median, it will be calculated the total 4 images median value and make only one composite or 1 images. Okay, and this is
so
the
that will be used for this.
Yeah.
So this is the, if you're using the median, that means it using some statistical calculation, and it would disturb the main original value of the image.
No, in this
what
time
kind of analysis you will carry out with the median?
I want to use the median composite. It means that in this time I get the total 4 images. 4 images when the messing the band value. Suppose 4 images messing the band value 1 by 1. From this you take the median value. Okay, and when I want to work with this only for the single image, it means that there is the no median value or there is the no anything. Okay, in this time this image is creating by the median. Total 4 images get the median value statistically, get the median pixel value and create the one composite from the 4 images. Okay.
So this image used for what purpose?
So mainly this image we can use that any types of remote sensing work. There is no problem, but you need to mention this method how you can get the image, how you can create this composite. Okay.
This is as for my knowledge, if you take the medium like this, because in Bangladesh or India, another scenario, we have the tropical forest, and there they have the vegetation. You cannot be calculated with the NDVI because the value is changing from the season to season.
Yeah.
And you take the median, so you are playing with the pixels with the wrong informations. So I think this is only used for the land use land cover.
Yeah, land use land cover. Yeah. It's only for the use the land use land cover, because when I want to get the median, then I can get the better visualization than single images. Okay, and it's created the all of the images 4 images median pixel value. Okay, so it's better for making the land use land cover classification. Yeah. So this is the one point.
Got it.
Okay.
Yeah.
So in this time you can see I can get this satellite images, and now I can make this LULC type of map in this satellite. So in this time I get the satellite image. Suppose you want to export this satellite image for as a TIFF format. You want to export this satellite image for working with other software, ArcMap or QGIS. So you need the satellite images. So for this I need to export this satellite image. So when you want to export the satellite image, previously I also tried to discuss about that. Export image to track. Here I can get all of the argument. I want to make the dictionary.
Yeah.
Okay.